Alright, hey guys, we're going to be talking about summarizing data using graphs and tables. It's not a super thrilling sounding topic, but it is super important in science. So let's get into it. Why is it important? Well, visualizing data really helps you see patterns in the data if there are any. Plots provide an informative summary of the data, which is really helpful because a lot of data sets have like thousands of bits of data in, and humans are visual creatures, to be honest. We don't do well with large amounts of like random abstract data and numbers of such. If you just throw that at someone, they're going to look at you with blank eyes and then leave, and I wouldn't blame them. So we need to have a way of having an informative summary of it, and that's what plots do. And then tables organize all your data, numerical, text, or whatever, into rows and columns, which means that you can read it and see and compare and understand what's going on, because an unorganized data set is one that's basically impossible to understand and use, especially if you're not the one who even collected the data in the first place. You have to be able to have it organized, otherwise it basically means nothing. So, plots versus tables. Plots are essentially graphs. You know them when you see them. It helps show trends in the data set. And then a table is essentially organized written data. So, here's a table. You can see it's got the column labels and stuff up here in the overarching units. And then over here you've got a plot or figure, graph, whatever you want to call it. So, how to read plots. Plots come in a variety of types, but mainly what you're going to see throughout your life are going to be bar plots, pie plots, scatter, and then line plots. And then which one you use depends on your data set, so it's all kind of conditional. There are certain data sets that look really good in a pie format, and other ones that would be the dumbest looking graph ever. It just depends. And then when you're reading them, three main questions to ask are: what do the axes represent? What are the units? What do the data points represent? And then what is the overall trend and message conveyed by the plot? So here's one. Sort of, those questions aren't always like the most applied, but anyways, so for axes, on the y-axis you've got proportion of canine teeth, and then down here you've got the diet type, so herbivore, carnivore, omnivore, proportion of canine teeth. This is like your canine teeth are small proportional to the rest of your dentition, and then up here your canine teeth are very large compared to the rest of your dentition. Units, I'm sure, would make more sense with the paper. But since it's a proportion, it'll be like bits of probably like length, but proportionally compared. And then, data points represent, well, the size of the canine teeth in proportion to the rest of your dentition, essentially. And then overall trend, as you can see, and like we just talked about, carnivores have very large canine teeth proportional to the rest of their teeth. Omnivores also have pretty large canine teeth because they have to, function for both eating meat and then also for plants. But herbivores, since they're not capturing critters, they tend to have very small canines proportional to the rest of their teeth. It's probably right in line with them or non-existent. So, it's kind of the basics of that. Each graph looks different, each plot looks different, but those are the main basic questions you should ask, and sometimes they'll be more clear than other times. So here are the basic course guidelines for tables and plots. So I'm just gonna read it straight because I don't want to give y'all the wrong idea or say something wrong. So tables neatly organize your data into rows and columns, and you need to have headers that clearly state what the data values are that you're presenting. And each table should include a descriptive caption above the table. Keep that in mind. Figures, so like plots and stuff, must have a descriptive caption below the figure. All axes have to be labeled. If you are using a symbol or a color to like define groups in your plot, you need to have a legend, or it needs to be described in the figure caption. And make sure your figure clearly distinguishes groups or treatments. If it's a plot, it traditionally will have your main title of the plot, your x-axis, so that'll be the independent variable and treatment, and then your y-axis is usually the dependent response variable, or what you measured, basically. Axes also need to be labeled with units and use a proper scale. So, it's kind of the basics of that. When you're making a figure, something to keep in mind, I had 2 colorblind friends in a class of 7 last year, and trying to read plots with them was pretty difficult sometimes because they were unable to distinguish basic colors that I could. So keep colorblind people in mind, otherwise they are completely unable to tell what you were trying to say. That's just my last note there. So keep all this in mind, do your best. Graphs can be hard, I get it.